Okay, so I'm a Rick and Morty fan, and I also enjoy creating content about AI. If you mix both, you'll end up with the video I bring you today, Rick LLM, or how to fine-tune Llama 3.1 to talk in Rick Sanchez style. Interested? Welcome to the Neural Maze. Hey, what's up guys? Welcome to the Neural Maze. Today we are going to explore my latest project, Rick LLM, in which we are going to make Llama 3.1 8 billions talk in Rick Sanchez style. Of course, Rick Sanchez is the main character of the Rick and Morty show. I guess you all know the series. So yeah, this is basically the project that we are going to build today. I'm going to show you how to create a Hugging Face dataset. I'm going to show you how to use Unsloth to fine-tune your LLMs, how to use Lambda Labs in case you are GPU poor, like me, and I'm going to show you how to take your fine-tune model and to deploy it in Ollama. Okay, so this is everything for today, and I have summarized all the different components of this tiny project in this diagram. You know that I love doing diagrams, and this is not an exception, and I think they are really cool if you want to more or less understand what we are going to build. Like, it gives a really clear idea of the project. So I like to say that this project can be divided into three parts or three components. The first part has to do with dataset creation. It involves from step 1 to 5 in this diagram, and in this dataset creation pipeline, let's call it that way, we are going to take the episode transcripts and we are going to generate an instruct dataset from this episode transcript from Rick and Morty episodes. Okay, so we are going to build this dataset using a dataset style called ShareGPT, and we are going to push this dataset into Hugging Face. Okay. After that, we are going to use, this is the second part, will involve all the fine-tuning process, and we are going to take the pushed dataset, the instruct dataset, and we are going to fine-tune the LLM, in this case Llama 3.1 8 billion, using a library called Unsloth. But we are not going to do it locally, since, as I was saying, I'm GPU poor. I'm going to do it using a GPU cloud called Lambda Labs, and I will show you how you can launch your own instance in Lambda Labs, how you can delete these instances, how can you train your models using this cloud. After that, when the fine-tuning job is finished, it's going to push both the GGUF file. I will show you what it is as the video progresses, and also the model file that we will need to Ollama to run. Okay, the Unsloth job is going to push these two files into Hugging Face, and then these two files are going to be loaded locally by Ollama so that we can start chatting with Rick Sanchez in our laptop. Okay, I hope this sounds interesting to you, and yeah, then you are looking forward to exploring this project with me. So without further ado, let's begin. Okay, so the first thing that you should do is to clone the repository. Okay, after you have cloned the repository, you will have something like this. Remember that all the steps that you need to follow to configure the environment variables, etc., are in the README. You can access the README, of course, both in the local version of the project or in the GitHub organization of the Neural Maze. But you can go here, and apart from high-level overview of the project, you can also check how to configure all the environment variables. In this case, we will need the OpenAI API key. This is for some of the steps that we will need in the dataset creation and cleaning process, the Hugging Face token, and the Lambda API key. Okay, I'm not going to get into the details of how to access and how to generate all of these API keys. That's something that you can explore, and I even put some instructions in here in case you want to check it. Okay, but after you have all the 3 API keys available, then you can copy this env example file where I put like placeholders for the different keys that we need and generate your own .env file that I'm not going to open. Okay, so this is everything in terms of configuration. Apart from that, I just wanted to mention a quick mention about UV, because I have replaced my poetry projects with this new framework. It's called UV for dependency management. So if you go to README, you will also see that I'm using this this new framework for installing the dependencies, etc. Okay. All right. So let's begin with the dataset creation. Remember that the first part of this project involved creating an instruct dataset that we were going to use for fine-tuning the model. So if you go to source, inside source to the dataset folder, the dataset module, here you have all the relevant code necessary for the dataset creation. If you go to the bottom of the script, you will find this main function that contains the three basic transformations operations, and then the push to Hugging Face, this push to have. Okay, so let's explore each one of these transformations. So the first one is this load Rick and Morty dataset, which, as you can imagine, is pretty straightforward. We are just loading an already existing dataset from Hugging Face. So kudos to Prarabdha, who created this dataset containing different transcripts of Hugging Face, of Rick and Morty episodes. After we have loaded this dataset, we are going to create conversation pairs. And what do I mean by this? Conversation pairs are just a way for the LLM to understand the type of data that we are passing. I mean, remember that we are dealing with transcripts, but we need to give these transcripts a way for the LLM to understand the instructions. Remember that in a instruct dataset, we have to put like the user input and the expected output that the LLM has to provide. So how are we going to do this in this Rick Sanchez LLM? We are going to do the following. So human, in this case, the human prompt is going to be the lines or the dialogues spoken by the non-Rick characters, like Morty, for example. Morty would be a human prompt. And Rick would be the expected response by our LLM. So Rick would be of role type GPT. So if with this step, this create conversation pairs, we are going to take each line of the script and we are going to transform all the script into this format. We are going to put a system prompt, which is going to be the same always. We're going to establish the human prompt with a value of the character that is currently speaking with Rick. And we are going to establish the GPT prompt, which is just the Rick response. All right. Yeah, that's basically for the conversation pairs. In case you are interested, that dataset style is called ShareGPT. And after that, we are going to add an additional operation that is going to clean the conversations. Because what I found by exploring the original or the raw content dataset is that in some cases there were inconsistencies in the dialogues. Like, for example, there were additions of descriptions of the emotions of the characters, or facial expressions, or scenario descriptions, stuff like that, that we don't want to add into our instruct dataset. All right, so that's the reason why I'm adding this clean conversations operation. All right, that's basically going to clean the operation. And this is the step where we are going to use, by the way, before I forget, where we are going to use this OpenAI client. All right, that's the reason why we needed the OpenAI API key. We are just going to clean all the conversations, and the output style is going to be exactly the same as the one we generated, I mean, in ShareGPT style, but with cleaned dialogues. All right. And finally, we are just going to push this dataset into Hugging Face. In my case, of course, I'm pushing everything into the neural maze organization, but you can go to the code and simply like modify anything you need. All right, so let me show you now what you will find if you successfully push the dataset to your Hugging Face account, or maybe if you start loading my own dataset. I mean, it's completely free, it's public, so you can use mine. So you will find something like this. This is the dataset, the final version of the dataset, and if you click any of the rows that it has a total of 1.51k rows, which is not a lot, to be honest, but I couldn't find more transcripts, so that's what we have to train. But yeah, let's explore the first row, for example. So the first JSON that we will encounter is this system prompt, okay, which has the following value. You are an interdimensional genius scientist named Rick Sanchez. Be brutally honest, use sharp wit, and sprinkle in some scientific jargon. Don't shy away from dark humor or existential truths, but always provide a solution, even if it is unconventional. Okay, so this is the system prompt that's going to trigger the generation of every row that you might find in this dataset. Then we have the human prompt that says, oops, what Rick, what's going on? This is a Morty line from the first episode, by the way.
Morty, you gotta, come on, you gotta come with
What,
me.
Rick? What's going on?
I got a surprise for you,
It's the
Morty.
middle of the night. What are you talking about?
And then we have Rick response, which is the GPT response. I got a surprise for you, Morty. All right, so if you keep scrolling down, you will see that the structure is always the same. And that's exactly what we are going to feed to our to Llama 3.1, okay, when we fine tune it. All right, so now that we have covered the dataset creation, let's go back to this diagram. We need to understand how to fine tune the model, all the fine tuning code using Unsloth, the library, and also how to train this if you don't have a GPU using Lambda Labs. So let's jump right into it. So let me show you first of all the fine-tune code. So for the fine-tune code, I want to focus on this script right here. It's called the finetune.py script. It's really self-explanatory as well. And this is the script that's going to be called by Lambda Labs when we fine-tune the model in there. All right. So the script is really simple, but it calls a lot of different configs and helper functions, etc. So I just wanted to give you like a quick explanation of what is happening here. The first operation, this initialize model, is very simple. I mean, it's not complex. You are just loading the model using the fast language model abstraction from Unsloth. You are loading both the model and the tokenizer. All right. We are using these constants right here. They are in a script, in a module, Python module called constants, where I have defined some relevant constants and parameters, and they are distributed or structured based on the meaning. Like for example, we have the maxsec length, but then we have the model config, we have the PFT config, and also the training args. We are going to see each one of them and when they are applied. So for the model utils, you can see that we are just taking information from the model config dictionary, the model name, if we want to load it in 4 bits or not. In this case, we are not loading in 4 bits since we want to fine tune using the LoRa technique and not the QLoRa. And then the D type. If you go to the constants, you will see that the model name is Meta Llama 3.1, 8 billions. Load in 4-bit, it's false because we want to apply a LoRa fine tuning. And D type is none because we want for the system to automatically check the specific D type, okay? And that's everything for the initialize model helper. Now that we have the model and a tokenizer, we need to set up the PFT model. And we are going to pass the model that we have just fetched. And in this case, we are going to apply some helper functions from Unsloth, this getPFT function. Okay, we need to pass, that is true, the PFT config, and this is probably the trickiest part or the most difficult part to understand if you haven't worked with LoRa fine-tuning before, because there are a lot of different parameters that you might be wondering, what is that? For example, R stands for the rank. This is the alpha parameter, the dropout, what modules you want to target when you fine-tune, because you can fine-tune to the keys, to the values, to the queries in the attention projections, etc. There are a lot of things that you can target, and to fully understand this, I would recommend you to go to Unsloth documentation. And inside documentation, in the beginner section, there is a LoRa parameters encyclopedia, which has a very comprehensive and interesting introduction to the different parameters that you might find in any fine-tuning job. Like, for example, R stands for the rank of the low rank decomposition, the LoRa decomposition. LoRa alpha stands for the scaling factor for the low rank matrices contribution, the dropout, what is the Ars LoRa, the low FTK config, etc. So you have a lot of information about the different parameters, which I'm not going to cover here, because it will involve getting into the papers about LoRa, about QLoRa, etc. So you can safely go to the documentation and read about any of them. Like the only thing that I want to mention is that for the rank, I've chosen 32, and for the LoRa alpha 64. And the reason this is the double is that reading through the Unsloth documentation, I found that it's generally recommended for the alpha parameter to be superior or to be equal or more than the rank. That's exactly why I did this. Okay. All right. So now that we have the PFT model, it's time to instantiate the core class that I have defined in the fine-tune code, which is the model trainer. The model trainer is going to accept as arguments the model and the tokenizer. Let me show it right here. And it has a set of helper functions for loading the dataset, preparing the dataset, and setting up the trainer function. This is the entry point to the class. Okay. In case, in fact, if you go to the fine-tune module again, you will see that here we are calling the setup trainer. And this setup trainer is going to follow the next workflow. So first of all, it's going to load the dataset. This is the dataset that we pushed into Hugging Face a few minutes ago. All right. Then it's going to prepare the dataset. And you might wonder, what does it mean to prepare the dataset? So if you remember, let's go back to Rick and Morty dataset. We have the dataset in this JSON style, okay? But you can't feed this to an LLM. You need a way for the LLM to really understand how to process this text, okay? You need to transform the system, the user, and the GPT prompt into text, into coherent text that you can send to the LLM. And that's exactly what we are going to do in the prepared dataset method. We are going to apply a chat template to our dataset. In my case, I chose the ChatML chat template, which is very common, and you can find the structure in here. We are putting this IAM start and the system, and then the system prompt, if there is any. In our case, we have a system prompt. The same for the user, and the same for the assistant. And we put everything in there. So what this is going to do, this apply chat template function, which comes from Unsloth, is going to take the dictionary, the dataset, the Hugging Face dataset, and is going to create an additional column called text that contains the information of the other columns in this format, in this ChatML format. All right, and that's exactly what it's doing. This process, this prepared dataset. The content or the result of this dataset preparation is going to be stored in the process dataset variable, and we are going to use it later on when we called the SFT trainer. Okay. The SFT trainer is the abstraction that we are going to use for all the training process, and it accepts as arguments the model that we remember that these were just attributes of the class, the tokenizer, the trained dataset. It has to contain, remember, a text column with its HTML template, the dataset text field, which in our case it's called text, as I told you, the maxsec length, the dataset numproc, the number of processes if you want to run it in parallel. Packing true, this is really useful if you want it to be really fast. I mean, it speeds up a lot the process, so set it to true if you want it to be fast. But it is true that it might affect the memory. Okay, it will consume more memory. And finally, the training arcs that you can find here. Let me show you. Oops, no, this is the default training arcs. The training arcs that contain, I think maybe these parameters are more familiar to you if you have worked with deep learning, machine learning models in the past, and TensorFlow, Keras, stuff like that. Learning rate, the train batch size, the scheduler type, accumulation steps, stuff like that, and maybe you are more familiar with it. I'm training for Firefox. And apart from that, I don't think there's anything memorable about this configuration. All right, so we have the training arcs and we have the SFT trainer ready to be created. So now we have the trainer instance, this SFT trainer, and we can simply call the train method. And this is everything. After we have run this line, the fine-tune process will start. And when it finishes, we are going to push the GGUF file and also the model file into another Hugging Face model, another Hugging Face entity. In this case, it's a model. In my case, of course, I'm pushing everything into the neural maze organization, but you can change this direction, this URL, if you want. And we are also pushing, of course, the tokenizer and getting the token from the environment variables. All right, so this is everything. Of course, I have no local GPU. I have not a powerful GPU, at least. And that's the reason why we need to run all of this not on my local laptop, but in a remote instance. In this case, a Lambda Labs instance. And that's exactly what we are going to see right now. So before we start, let's go here, because we are going to follow the README. I mean, I'm not going to explain in detail how to log into Lambda, how to create your own account, etc., because I don't think the value of this video is related to that. You just have to follow both Lambda instructions on how to create an account and also the README file, because it's really, I can assure you that it's really easy to configure, and it's really easy to launch a new instance. But if we go to running the project and to 4.4 in the README file, you will see that we have a launching a Lambda Lab instance. I have created some makefile commands that will help you a lot in the process of generating all this Lambda workload. So if you are interested, although as I mentioned, it's not going to be the core topic of the video, you can go to source and Lambda folder. And in here, I have defined inside comments a list or an implementation of all the different URL endpoints that you might need if you start working with Lambda. I didn't find any Python API for Lambda. That's the reason why I decided to do it myself. In fact, if you think this might be, I don't know, useful for anyone, maybe you can take this code and create a proper Python API, or if you're aware of a proper Python API for Lambda Labs, you can let me know in the comments. I will be really grateful to you. But yeah, just a very fast look at this. I have defined functions for generating SSH keys, listing the SSH keys. Of course, SSH keys are necessary if you want to connect to a Lambda Lab instance. locally. That's exactly what we are going to do. List the instances that are currently running, list the instance types, that is the type of GPUs that you might use, get the IP or the ID in this case of the VM, of the virtual machine that we are going to use to fine-tune the process. Do the same, but getting the IP. This is necessary when we sync both the local file system and the remote file system, and launching the instance. This is probably the most important one because it will do everything for you and you don't need to bother about anything at all. And finally, terminate the instance because we don't want to overpay. So when we are ready, we can simply kill the instance. All right, perfect. So now I think I'm going to move to a terminal because I think it will be easier to understand. And I'm simply going to follow this the README file. Okay, so first of all, let's launch the Lambda instance. Okay, of course I have all my all the SSH keys already defined, already stored in Lambda. I have make commands for that, so you can follow that in the README file. But in this case, I'm just going to show you how to launch the Lambda instance. Okay, let me show 1 second. Okay. All right, so what this is doing, this make launch Lambda instance, is to create a new instance inside my Lambda account. Okay, you can see here that there's a new instance in a status of putting. So we will wait for some time until this is green, and I will come back to you when this is done. Okay, so the Lambda instance is now running, as you can see on the screen. So now it's time to keep running all the additional commands that we need to start the fine-tuning process. So the next command involves getting the IP of the instance that we have launched in Lambda. And you might ask yourself, why do we need the IP? So the thing is that if we go to this design again, you will see that in steps 6 and 7, we need to sync the local file system with the remote file system. What we are going to do basically is to copy all the code that is inside the Rick LLM folder with all the modules that we need for the fine tuning, and also copying the makefile and the environment variable, because we will need all of this information, we will need all of this code and information in the Lambda instance to start the fine-tuning process. And that's also the reason why we need the IP, because as you will see, some of the commands that we are going to run involve the IP. All right. So after we get the IP, let me run the command. I thought I had. Okay, so this is my IP. You will get a different one, of course, but after we run the IP, we need to start the syncing process. So the first thing that we're going to do is to upload both the makefile, the environment variable, and also the requirements. There are some specific requirements we need to add to the Lambda instance. Otherwise, I don't know why, to be honest, but it was failing. So I had to do a lot of research in terms of all the different packages that I had to install. To be honest, it was a bit of a hell, a lot of dependency issues. But yeah, this is going to upload the env with all the environment variables, the makefile, and also the requirements. All right, perfect. Now we also need to upload the proper core logic containing all the fine-tuning code, the one that we have been discussing in the past half hour. And we also need to copy the IP here. Okay, and we are basically uploading Rick LLM folder. All right. Nice. So we have successfully uploaded all the data that we need to start the fine-tuning process. Now it is time to log into the Lambda instance by using SSH. So this is very simple. We use the SSH command, and surprise, surprise, we are inside the Lambda command. All right. Okay, so here we are inside the Lambda instance. To check that everything is on site, you just need to run the ls command, and you will see here the make file, also our requirements Lambda containing the different dependencies that we need, and also the source folder that contains the Rick LLM folder, which, as you might remember, contains all the modules and Python files that we will need to start the fine-tuning process. So that's everything. Let's go to this folder again. Now, before we start the fine-tuning process, there's just one missing part, and that's related with setting up the Lambda instance. And what do I mean by this? What I mean is that, like this, the Lambda instance is not ready to run Unsloth. And the reason is not very difficult to understand. It's just that there are a lot of dependency issues. I mean, I've been working for a few days in this project, and I can assure you that 70% of that time has been invested in doing research and learning why I was having so many incompatibilities and dependency issues between Unsloth and PyTorch and transformers, etc. All these libraries with the CUDA kernels that are used by this instance. So don't panic, because I have one idea. Well, no, not one idea. I mean, I have one. So don't panic, because I have one solution, and that is to use this command, make lambda setup. That is going to use one of the commands that I have defined that takes care of updating the system, upgrading the kernel, also installing different and specific requirements that we need for Unsloth to work, etc. So instead of going through this pain yourself, I would encourage you to simply use my command. Okay, life will be easier this way for you. All right, so just make lambda setup and wait for around 5 minutes, more or less. And after this is finished, then we will be 100% ready to start the fine-tuning process. So I will pause the video now, and I'll see you on the other side. Okay, so here we are in the fun part of this project, fine-tuning Llama 3.1, that we can achieve with a very simple command, make fine-tune. This command is just going to run the source ricklm finetune.py, which we already know, and as the output is going to push both the GGUF file and also the model file into Hugging Face, into my organization, the Neural Maze organization. So yeah, let's wait for a little bit to see that everything is working as expected. So here it's just downloading the different model weights, it's loading the dataset, etc. And now it has started the training process, the fine-tuning process. You will see that it's quite fast. So this is one epoch, and yeah, and we can check here how the loss is going to decrease. Yeah, it's the second epoch, and yeah, this is basically the fine-tuning process. So we will wait for 5 minutes more or less, and after that we should see the GGUF and also the model file in Hugging Face. So I'm going to pause the video and to show you the file results.
Wubba lubba dub dub!
Okay, so the fine-tuning process is already done, and now I'm in my Hugging Face account, where you can see, let me go to the base folder, here under models in the Neural Maze organization, you will see, let's click files and versions, you will see the model file and also the GGUF. Okay, so the missing part that we need to do now is to download both the model file and the GGUF to the local file system, and then to create the Ollama model. And this is really easy, as you will see, since I have created some commands for you to run. So let's go to the README, and here, oh, by the way, don't forget, I have already terminated the instance, but don't forget, please, listen to this, don't forget to terminate your instance, otherwise you're going to hate me. if you forget to kill the instance in Lambda Labs, because the build is going to be, let's say, surprising. So please terminate your instance. You can simply run this command right here. But now, as I was saying, we are going to download the model. Oops, yeah, let's do it here. I think it's easy. So you simply download the model, and it's going to be downloaded here into the Ollama files. I already have the model file and the Unsloth, the GGUF, since I was doing the same before. But yeah, so we are going to download the model file and also the GGUF containing the model weights quantized. And now let me show you how to create the Ollama model. This is something that I have explained in my previous video in the channel, how to create new models in Ollama using a model file as the blueprint for the models. In my previous video, I was creating not a fine-tune, but a modified version of a Llama, like a Llama model. In this case, we are going to read from the GGUF. So let me show you the model file. If you go to the model file, you will see that in the from statement, we are reading the Unsloth Q8 GGUF. And the rest of the content of this model file, as I was saying, they are explained in my previous video. But here you have the template with the ChatML template that we defined, but we were fine-tuning the model, and then different parameters that I thought they were interesting, like the temperature, the mean p, and also the system prompt that we have used to trigger each one of the generations of Llama. Okay, so if we do this, hopefully we will create the Rick LLM model, and after that we can simply start using the model. So I hope you are excited about this. So this should be pretty fast. Okay, so now if we run Ollama list, here it is, Rick LLM. We are very close to a successful ending of this video. So now just Ollama run Rick LLM, and ladies and gentlemen, here we are in front of Rick Sanchez on a local laptop. This is probably one of the biggest achievements in humanity. So hey, what's your name? It's going to take a little bit. Okay, yeah, that's fine. I'm Morty, by the way. Let's try to roleplay a little bit. I'm Morty, by the way. What science stuff. Okay, so I like the style. Listen to this giant head in the clouds that makes rainbows with his tears. Okay, I like this. Do you believe in science, Rick? Science, no? Really? It's just a bunch of made-up words for stuff that already exists. I don't think Thomas Edison had to take college science courses to invent the friggin' light bulb. Okay, I really like this LLM. I think I'm going to substitute this LLM as my coding assistant. It will be really cool to have Rick Sanchez criticizing your Python code. So yeah, this is everything for today. I encourage you to pull the code and to start building everything yourself, even training for more epochs, or even improving my current output, my current LLM, because I think we can make an even better Rick Sanchez. And I would love for you to share your Rick Sanchez LLMs with me, both in YouTube and also on LinkedIn, or whatever channel input that you want to use. So yeah, this is everything for today. As I was saying, I hope this has been a fun way to learn about fine-tuning, about Unsloth, and also about how to deploy everything into a GPU cloud. So yeah, I guess I will see you in the next video, and until then, happy coding. Goodbye.
sure they see the sun. Goodbye, moon man. You say goodbye.